Okay, alright guys, so this is day 1 of week of April 27th, and we are going to talk about independent and dependent events and how to find their probabilities. What you're going to learn is how to determine if two events are independent and how to determine if two events are dependent. Where is key vocab? Okay, so independent events are, we've got these definitions written down already, but I'll go again. Independent events mean that the probability of one event does not affect the probability of another event. So if you have something going on in an experiment, and let's say you have two or more events going on, the probability of one event doesn't affect the probability of the other event, then those two events are independent. Dependent events, if you're doing an experiment and you have some things happening, it means the probability of one event does affect the probability of another event. So that means in that experiment, if I'm doing two or more things, that means that one event is going to mess with the probability of the other event. I'll give you some examples as we work. It says, now, normally if you see keywords or something in this area, with replacement means to put back. So if you're doing an experiment and you take an object out, let's say you have a thing of marbles, and you take one marble out, before you do the next event, you put that marble back in, then that means the two events are going to be independent. So normally when you see with replacement or something indicating with replacement, that's a giveaway that that's an independent event. Okay? Now without replacement means, let's say you have a bag of marbles and you want to do an experiment. Let's say you do the first event, you take a marble out, but you don't put that marble back. So what that means is that now you're going to affect the probability of the other events that you do within that experiment because you're not putting that marble back. So without replacement would mean to not put back in the set. And normally those events end up being dependent events. And that's pretty much what we have going on with our key vocab. And we'll dig into this more. Okay, so it says, question 1, it says each of the letters A through J are printed on tiles that are placed in a hat. Andre selects a tile at random and then replaces it. Clara then selects a tile at random. What is the probability that Andre selects a tile labeled B? Okay, so we're talking about letters A through J. So the first thing we need to figure out is how many letters are in here so we can find probability. Because probability means what you want over the total number of outcomes, which is the sample space. So I'm going to say A, I need to count the total, I need to get the sample space here. So A, B, C, D, E, F, G, H, I, and J. Alright, so all of these letters, and what's the probability of getting B? So the probability of B, and this is the answer to question number 1, would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my sample space is 10. And the probability of getting a B, that shows up once, so that's 1 out of 10. Okay, number 2, it says what's the probability that Claire selects a tile labeled B? Well, if we look here, it says that Andre selects a tile at random, then he replaces it. So if he replaces it, that means that my sample space is going to be the same here. So the probability of getting B for Claire would also be 1 out of 10 because he put the letter back. Okay, what is the probability that both Andre and Claire select a tile labeled B? All right, so this here is what we would call conditional probability. So with number 3, it wants to know what is the probability of Andre and Claire getting the tile labeled B. So there's a couple of things we can think about how is this going to happen. So if Andre go first, so we say that this would be if Andre goes first, then the probability of Andre, I'm going to write this mathematically. So first I want to say what's the probability of Claire, well we'll go ahead and say what's the probability of Andre getting the letter B, and then I want to multiply that by what is the probability of Claire getting the letter B after Andre has gotten the letter B. And the situation tells me that they both replace, well, Andre replaces it. So we're going to go here and say this would equal the probability of Andre selecting the tile would be 1 out of 10 times the probability of Claire getting the tile. Well, if Andre puts it back, that means Claire is going to have the same probability. And so the answer to this would be equal to 1 out of 20. So we're multiplying those two probabilities together. All right. So we're done with that, and this is this would be Claire getting a tile after Andre has done it. Okay, and so in math we read that Claire getting a tile, given that Andre has already done it. Okay, so let's go to number 4. Number 4 says, are the events selecting a tile, the events Andre selecting a tile and Claire selecting a tile dependent or independent? Explain your reasoning. Well, in this case, since Andre puts the tile back, then them selecting the tile right after each other would be independent events. The word with replacement told on that. So these are independent events because Andre puts the towel back. Andre replaces the towel. So the probability of the second event is not affected by the first event. So these are independent events. Alright, so one way you can think about that, as long as the two events, I'm going to leave that alone. So there we go. So that's the answer to question 1 for our practice. Do we have another one? Okay, so we're done with today. So make sure you go to Canvas and work on your practice problems. Bye, guys.